In this video, we're going to talk about integration. So integration is basically the opposite of the derivative. So it's like the inverse of the derivative. So if we have the integral of f prime of x dx, this will be f of x. And then because we're integrating, we don't know what the constant's going to be, so we have to add c. So this is arbitrary. So if you have let's say we have the integral of 2 dx. So what f of x will differentiate into 2? So that would be 2 times x plus c. So basically what this says is any line with, let's say c is here. So if we plug in 0, c would be here. So any line, the slope measured at every point will be 2. And so this function the derivative of this function at every point will be 2. So even if we move c to be like here, let's say that this c prime, just as another number, this will have the same slope. So the integral of 2 dx is 2x, which is like the starting function, plus any constant. So like anything to move it up 1. Another example of this would be, so we know that the derivative of x to the n is nx to the n minus 1. So if we want to find out the integral of x to the n dx, what we would do is we would divide by n, so we get that x to the n minus 1 is the derivative, and we can divide the n into the derivative, so we have x to the n over n, and then we can add 1, we can make n go to n plus 1, so let's increment all the n's. So we have derivative of x to the n equals the derivative of x to the n plus 1 over n plus 1. And so by this, we basically have the integral of x to the n. Well, that's basically like the function that differentiates into x to the n, which is exactly this. So this is just x to the n plus 1 over n plus 1 plus c. And we call this rule the reverse power rule. So the power rule is this, and the reverse power rule is this. So this is the reverse power rule. Is this. So that's the end of the video.